I'm Anil Kumar, and here is a very popular question which relates to tangent ratios in right triangle. The question is, a GUI wire fastened 35 meters from the base of a television tower makes an angle of 50 degrees with the ground. How high does the GUI wire reach? And part B is, how long is the wire? Now this is a very interesting question. At this stage, I'm assuming that the students have just learned about the tan ratio, right? They really don't know anything about sine and cosine. That is an assumption, and with that assumption we are going to solve this particular question, correct? So the question is, a GUI wire fastened 35 meters from the base of a television tower makes an angle of 50 degrees. So let's say this is the wire which makes an angle of 50 degrees. Okay, so it is fastened here, and it is given to us that it's fastened 35 meters from the base. So that is the base of the tower, and the angle here is 50 degrees. Okay, that is the angle with the ground which the wire makes, correct? And let's say this is the tower, and that's the point T, right? And that is the bottommost point, let's say O, and let us say this is P. Okay, so that is kind of a right triangle which you have, right? Because tower is perpendicular to the ground. Now let's look into this question once again. How high does the GUI wire reach? So that means we need to find TO, that is the height, correct? So we need to find this height, so that is the height H. How are you going to find the height? So that is an application of tan ratio, correct? We are interested in finding the height which is opposite to the given angle, and we know the adjacent side between the angle and 90 degrees, correct? So therefore we can write here that tan of 50 degrees is equal to opposite side, which is the height which we need to find. You can write TO or H. So let me write TO for the time being, divided by adjacent side, which is 35. We'll write meters in the answer. Okay. So what is TO? So we'll cross multiply. These are the ratios. So we say TO, or in our case height, which is equal to TO, is equal to 35 times tan of 50 degrees, correct? So that is how, using tan ratios, we can get our answer. So that is 35 times tan of 50 degrees equals to 41.71. So we get 41.71, and the unit should be meters, right? Since 35 was in meters, so if you write units here, you get units here also in meters, same units. So the answer is, height is 42 approximately, right? Say approximately 42 meters. Okay, so that is the height it can reach. Now the question is, how long is the wire? How do we find that length? At present we know what is PO and what is OT, and this is POT is right triangle, so we can use Pythagorean theorem to find the length of the wire, which is PT, right? So at present I'm assuming that we don't know about sine and cosine angles, and therefore we are not using those methods. We'll soon learn that in the coming chapter, and then we'll apply or do this question in a different way or alternate way also. So to find the length of the wire, which in this case is PT, we can say PT square is equals to PO square plus OT square, correct? So which is, PO is 35 square plus, let's use two decimal places, 41.71 square, correct? So now we can find what PT is by doing a square root of this, and you have to take positive values, correct? So we have 35 square plus 41.71 square root, correct? Use the calculator once again, find your answer. So we have square root of 35 square plus 41.71 square equals to. So we get 54.449. Units are meters, correct? So that is how we can find length of the wire. Now let us write on our answer. Assuming that we are rounding each number to one decimal place, right? So we'll round to 10th. So that is the rounding which we are doing. So rounding to 10th, we know height is equals to 41.7 meters and length is equal to 54.4 meters. Okay, so that is how we can solve this question. I hope that helps. Thank you and all the best.